Hey there, cosmic explorers. If you're not already in a comfy spot, now's the time. Maybe grab a drink, lean back, and prepare for a journey unlike any other. Because together, we're about to embark on a mind-bending voyage into the unfathomable depths of our universe. By the end of this, two possibilities await. Either you'll completely lose yourself in the sheer scale of it all, forgetting who and where you are, or you might just stumble upon a profound sense of your place within this grand cosmic tapestry. Ready for an existential adventure? Then let's dive in. Our starting point, our pale blue dot Earth. Now, while it might feel like home, a relatively small planet, let's try to grasp its size in a more tangible way. Imagine hopping into a car, cruising at a steady 60 miles per hour. To circle our globe without stopping for even a moment, it would take you over 17 relentless days. Think that's tiring? Even hopping on a commercial airplane would still have you in the air for more than 2 full days. So, not exactly a tiny rock, is it? And for hundreds of thousands of years, we've been navigating this very surface, building lives, histories, and yes, even conflicts that still seem to linger. Many lives end without ever seeing beyond their own small corner of it all. But our minds, they have no such limits. So, shall we leave our terrestrial abode and venture to our nearest celestial neighbor, the moon? In photographs and animations, it often appears so close, almost within arm's reach during a full moon. But the reality? A staggering 238,900 miles separates us. Back in our hypothetical car, maintaining that constant 60 miles per hour, a non-stop drive to the moon would stretch out for over 6 long months. 6 months. Though we did eventually make it there, didn't we? Humanity's farthest physical reach across the cosmic expanse. 12 individuals have walked upon its dusty surface, a truly remarkable feat. But our journey continues. Let's broaden our horizons as we zoom out further, the other planets of our solar system come into view. Again, visualizations can be deceiving, making them seem relatively close. The true distances, however, are almost impossible to intuitively grasp. Our solar system, in the grand scheme of things, is but a minuscule speck. To illustrate, let's get back in that tireless car and try to reach the sun. At our constant 60 miles per hour, it would take us approximately 177 years of continuous driving. Even by airplane, that journey would still be a staggering 19 years. The sun, seemingly so close, is astronomically far. What if we aimed for Neptune instead? Even more daunting. By car, a non-stop trip would take over 5,000 years. By plane, a mere 600 years. Yes, our solar system is vast beyond comprehension. Colonizing even just our local stellar neighborhood is a dream of immense proportions. We may not be able to travel these distances ourselves in a lifetime, but our creations have ventured far beyond. These robotic explorers travel at speeds far exceeding any car or airplane, often clocking in at 18,000 to 25,000 miles per hour, sometimes even faster. The most distant human-made object currently speeding through the cosmos is Voyager 1, launched way back in 1977. For over 43 years, it has been relentlessly pushing into the deep unknown. Long since leaving our solar system behind in August of 2012, it's currently over 13.7 billion miles away from Earth. If you could travel at the speed of light, reaching Voyager 1 would still take you over 21 hours. And you can still track its current location and trajectory on NASA's website. But now it's time to truly leave the neighborhood. Let's head out of our solar system. But where exactly is the edge? That's a question without a definitive answer. Some consider Neptune's orbit the boundary. Others point to the heliopause. But for many astronomers, the true edge lies in the Oort cloud, a theoretical spherical cloud of icy planetesimals believed to surround the sun at vast distances, containing trillions of comets. This uncertainty translates to unimaginable distances. Let's say Neptune's orbit is our solar system's edge. Traveling at the speed of light, it would take about 4 hours to reach it. But if we consider the outer reaches of the Oort cloud as the boundary, then traveling at light speed from the sun, it would take a staggering 1.5 years to get there. The definition of the edge drastically changes the scale. Just to reiterate how mind-boggling the speed of light is, at that velocity, you could travel to the moon in a mere 1.3 seconds and reach the sun in about 8 minutes. So even with the ultimate speed, venturing beyond our solar system is a journey measured in years. Our solar system, which felt so immense just moments ago, begins to shrink into insignificance as we compare it to our home galaxy, the Milky Way. Now, prepare for a true recalibration of your sense of scale. Our nearest star, Proxima Centauri, is approximately 4.2 light-years away. Sounds close, right? Let's try reaching it in our trusty car. How long do you think it would take at a constant 60 miles per hour without any brakes? Roughly 47 million years. In a hurry? Let's hop on a plane. Still a cool 5 million years. Feeling really impatient? What about a spacecraft traveling at Voyager 1 speed? That would still take about 73,000 years to reach our nearest stellar neighbor. Not exactly a quick hop, and considering human lifespans, that's about 2,500 generations. Venturing further, Sirius, the brightest star in our night sky, is about 8.6 light-years away. As we continue to zoom out, we encounter larger stellar neighborhoods, like the Pleiades star cluster, about 444 light-years distant. Some stars, though incredibly far, are surprisingly visible due to their sheer luminosity. Like Canis Majoris, a red hypergent roughly 3,900 light-years away. But within our local stellar bubble, a region about 50 light-years in diameter. Imagine trying to navigate that vastness. Even at Voyager 1 speed, traversing this local bubble would take around 1 million years. And as we leave this local stellar neighborhood behind, we encounter the radiosphere. The radiosphere represents the farthest extent of human-generated radio waves, the signals of our communication and broadcasts that have been radiating outwards since the dawn of the radio age, roughly around World War II. And this bubble? It's surprisingly small on a cosmic scale. It's just now reaching stars within a few hundred light-years. So, if there's an alien civilization in a more distant part of the Milky Way, they haven't heard our hello yet. A tiny whisper in an immense cosmic ocean. Within this radiosphere, there are an estimated 3,000 to 5,000 stars, within a sphere roughly 160 light-years in diameter. But let's venture beyond this faint bubble. Let's travel 1,000 light-years away. Seems incredibly far, doesn't it? But no, we're still within less than 1% of the Milky Way galaxy's diameter. Can you even begin to fathom the sheer size of our galactic home? An estimated 400 billion stars, all within a single galaxy. When we hear the word billion, our minds struggle to grasp its immensity. Just think about it. Counting to 1,000 takes about 17 minutes. Counting to 1,000,000? Roughly 12 days. But counting to 1,000,000,000? That would take you over 31 years. So, when we talk about 100 to 400 billion stars, we're talking about truly astronomical numbers. And I want to emphasize this because things are about to get even more mind-boggling. Within our Milky Way alone, there are hundreds of billions of stars. And if we assume that most stars have planetary systems, we're looking at potentially trillions upon trillions of planets. And all of this is contained within just one galaxy, our Milky Way, spanning about 100,000 light-years in diameter and roughly 1,000 light-years in thickness. To put it in perspective, if our solar system were the size of a dime, the Milky Way galaxy would be roughly the size of the entire North American continent. Finding a single planet like Earth in that vastness? It makes searching for a needle in a haystack seem like child's play. And remember, on that tiny dime-sized solar system, our Earth is a speck of dust, likely invisible to the naked eye. And on that speck of dust, that's where we are. And this is just a comparison of our solar system to the Milky Way. So, let's keep going. Let's break free and venture beyond our galaxy to our nearest large galactic neighbor, Andromeda, a staggering 2.5 million light-years away. And let's keep zooming out, expanding our view to a diameter of 110 million light-years. What do we see? We encounter the Virgo supercluster, a massive collection of galaxies, including our own local group, which contains the Milky Way and Andromeda, along with dozens of smaller galaxies. Within the Virgo supercluster are thousands of galaxies, each containing hundreds of billions of stars and trillions of planets. But we're not stopping here. Let's zoom out even further. We begin to see other superclusters forming an intricate cosmic web. Some regions appear dark, obscured by the plane of our own Milky Way galaxy, preventing us from seeing what lies beyond. As we continue our outward journey, we encounter quasars, incredibly luminous active galactic nuclei, powered by supermassive black holes dating back to the early universe. And finally, we arrive at the cosmic microwave background radiation, the afterglow of the Big Bang, the very birth of our universe. Looking at this map, we've essentially reached the limit of our observable universe, the farthest light that has had time to reach us since the beginning. This boundary encompasses a staggering 2 trillion galaxies, a number so vast it almost loses meaning. So, is this everything? Absolutely not. Currently, the diameter of our observable universe is estimated to be around 93 billion light-years. Beyond that, we simply don't know. But considering the accelerating expansion of the universe, the actual size of the entire universe could be 250 times larger, stretching across trillions of light-years. So, the ultimate question arises, what do we do with this knowledge? What does understanding the immense scale of the cosmos truly offer us? The answer, I believe, is deeply personal. But for all the great thinkers, philosophers, and scientists throughout history, the answer to this question is, in a way, the answer to everything. Our quest to understand the universe is intrinsically linked to our quest to understand ourselves. The better we comprehend the cosmos, the better we understand our place within it. Because ultimately, we are not just observers of the universe. The universe is within us, and we are a part of it. Biologically, we are interconnected. Physically, we are bound to our planet. Atomically, we are stardust, connected to the very fabric of the cosmos. And this awareness has the power to change everything. It reminds us to treat all living things, our environment, with respect and love. We might seem infinitesimally small and insignificant, but in our unique ability to contemplate this vastness, we are also incredibly special. Knowing that every atom in our bodies was once forged in the heart of a dying star ultimately reveals the insignificance of our petty squabbles, our wars, our fleeting worries. Our time is finite, precious, and should be cherished. Until our next cosmic rendezvous, take care and remember, you are a part of something truly extraordinary. And hey, if this journey made you feel even a little more connected to the universe, consider hitting that like button, maybe subscribe, and join me next time as we dive even deeper into the cosmos. Until then, stay curious, stay kind, and keep looking up.